Hello everyone, welcome to today's daily Leetcode challenge. Today is day 18th of it, and today we have a medium level problem designing browser history. Yeah, so it seems to be easy problem. The acceptance is high in this. We'll just try to see what this question is. So it's see before going to this question, it's all about how we use a browser in general. So how the browser is being implemented, we are just trying to mimic it. We are just trying to make a code for it. That's how it is. And going to the details of the question, here we are going to design three functions actually. One is the visit function, another one is the back function, and another one is the forward function. So what is going to happen is that we are going to make how we user uses the browser. We can go from one like URL to another. We can add another URL, then we can click on something and it will go to another web page. Like that, it can keep on going. So you might be thinking, yeah, stack could be a better option, and yeah, linked lists are also generally used for this. But we can also use dynamic arrays for like making a like track of how which URLs we're visiting. Okay. So what they are asking is we have to make a visit function. That means whenever I'm in one URL A, I can go to URL B if I click on somewhere. That we need to like code it. Then there are back functions as well. We can go back 2 to 3 times. Like in browser normally we'll press back button 1 or 2 times. So they have given us steps. That means this much number of steps we should go back, and the URL which was this much number of steps back, we need to return that. Similarly, the forward function here also, for suppose we have 10 tabs open and we are in the fifth tab. So they will ask some number of tabs to go forward, means which we have already opened. There we will go and return the URL. So you will understand this with examples. So I have designed example here, and I hope my screen is visible. I'll just increase the font. Yeah. So suppose this is the history you are doing. So first, this is order. Okay, this is order in which we are going to go to the websites. First, I'm in google.com. Okay, I'm in google.com. So this is my first website. Next, I am going to youtube.com from same like in Google. I click some link and it's coming to YouTube. Okay, now in YouTube, I'm clicking some link. It's going to share chat. Okay, next in share chat, I'm clicking some link. It's going to Twitter. Okay, this is the one. Yeah, now the trick comes. Now the question asks me to go 2 steps back. So what I have done till now, this is my history, okay? Now I am at Twitter. This is my current. Now the question asks me to go 2 steps back. That is, I am going back to YouTube, the one which I opened in the second URL, okay? This is the second one which I opened. Now the question asks me to go to 2 steps back. So what will happen now is there are many ways to do it. Either we can traverse back or see here they are telling one thing, visit na. Visit URL from the current page, it clears out the forward history. So if I go and visit YouTube back, it will clear the forward history. That means these will be it should be deleted. This is what the question's instruction is. Okay. So what I can do is either I can delete them or I can neglect them. This is the see deleting will take some of the time. Okay. Instead of deleting them, we can neglect them so that we can override them when that time comes. So what will happen is I'm using a variable called R limit here. So once I'm in YouTube, I will make it this as the R limit. Okay. So okay, I'm in YouTube. Next, I want to go to Yahoo. Okay, I am in YouTube. I want to go to Yahoo. That means in place of search yet, I am now writing Yahoo, and I'm making a variable which is R limit here. R limit tells me that you should not cross this boundary for your calculations because we know that Twitter. See, share chat we deleted and replaced with Yahoo because we are visiting Yahoo after YouTube. Okay, but Twitter is still there because we have not deleted it because we don't want to waste time deleting it. That's why we are creating a new R limit, which tells me that we should not cross beyond this. Beyond this, if we cross, we will get some old data which is of no use to us. Okay, so this is how it's being implemented. I will quickly show you the code. I hope so you will be able to understand it. Okay, yeah. So this is my constructor. I'm declaring a array which will store the initial home page which is given to us. I'm declaring R limit which is the limit. Okay, that I'm in the current. Current will tell me in which page I am currently in this array. Okay, current will tell me in which web page I am in this array. Current should not cross beyond this limit, beyond this index. Okay, this is the index. Remember, this is not see. Most people will confuse what is length. If length is n, then why we are taking n minus one. All these things. Okay, this is the index. This should be used as it is. Less than equal to greater than equal to like that. It should be used. It should not be less than or greater than. Okay, we'll use directly as an index. So current should not cross beyond this limit. That means if it is zero, current can be zero. If it is one, current can be one, but it should not cross. This is how I'm planning to use it. Okay. Now coming to visit functions, the one thing which you should remember from this question is that it is asking us to clear all the forward history. Okay, what that means is, suppose I have done this thing. Now I am going back to YouTube. Okay, if I am going back to YouTube from Twitter, after this is Twitter, I'm going back to YouTube. That means it is asking me to clear all the forward chat. This should be deleted. Okay, this is what they are trying to say. Either we can delete them, but see, it will take some time. Instead of deleting them, we can override them. This is what I'm trying to do. This is dynamic array solution. See, this question you can also solve using two-stack approaches, using double linked list or single linked list, or whichever way. Single linked list is not possible because you have to traverse back also. So these things also you can try. But I feel this is the best approach, and I will show you. I am getting 98%. I'm beating 98% of the solutions with my code. So I hope it will be the best way possible. So the visit solution, okay. So yeah, when it comes to the business solution, there are two ways possible. See, for example, I am at Twitter. I want to add something else. Okay, suppose I'm at Twitter. I want to add something else. This is the best case, like simplest case possible, because there is nothing. I'm at the end of the array. I'm adding something else. This is where this thing will happen. Okay, here we are appending it directly. No need to check any argument and all. Simply append it. Okay, this is what being done here. But for cases like here, where I'm in YouTube, I have something else here which is redundant to me. Instead of share chat, I'm going to replace it with Yahoo. In this case, R limit comes to picture. I need to update the R limit as well. Okay. So this part will be executed. Okay. Where the self.current is less than the last index, we'll execute this part. If the current is in the last index, then this part will be executed. If it's in less than the last index, this part will be executed. What happens is I will increment the current by one. Then for that position, I will append the URL. See, I'm not doing the append function. Append function will create an index. Okay, we are reusing or overwriting in that same index. Okay, and then we are setting the limit to the current. Okay, now coming to going back. Going back means, see, now we have to go some number of steps back. So what I'm doing is I'm trying to see if it is even possible or not. Okay, because in questions they have clearly mentioned return only case steps if it's not possible. Okay, so what I said that is I am subtracting current bit steps. Then I am checking if this minus is going greater than zero or not. If it is going, that means it's possible. So I will move my current to. I will subtract my current. I will subtract steps from my current. Okay. If that is not possible, that means its k is coming negative. So the least possible value is zero here. So I will like make current as zero, and then I will return the URL in the current index. Okay, current is zero, so zeroth index I will return from the history array. Okay, now coming to forward. Forward means we have to go some steps forward. Here, see, right limit will come into picture only in case of forward. In left limit, we already have zero as the limit, right? Zeroth index is already like a limit, so we are not having any variable for left limit. So what we are trying to do is, I'm first of all like checking if it's possible or not. Okay, server current bus steps. I'm making initializing variable k with that. Then I am checking if this variable is less than my k limit. If it's less than my k limit, I'm good for it. Okay, I can add steps to current. This is what being done here. Okay. Otherwise, if it is crossing some value, okay, I can go to a maximum R limit only, as I've already told. See, uh, I am at Yahoo YouTube. I want to insert Yahoo. So this will be my R limit. I can't go to Twitter because this is supposed to be deleted. I'm expected to delete this, but I did not do. So I cannot cross R limit at any cost in any forward operation also. Okay. So I am checking if it's less than my R limit. If it's less than my R limit, it's well and good. If it is not the case, I can go to maximum R limit only. Then I will like this is my current. Then I will return my current. Okay. So this was the solution. And coming to the time complexity of it, see, none of the steps we are like traversing anywhere. Okay. See, we are not traversing anywhere. We are simply changing the limit function and we are returning that value. Okay. We are dynamically accessing the element. We are not traversing like a linked list. Okay. In any of the cases you can see, we are not doing that. That's why it's O of one. Now coming to space complexity, see, here there are two variables. See, L is the average length. Okay, L is the average length of each of the strings. Average length of each of the strings of the URLs you can see. And is the number of times they are being sent. Okay, and is the number of times they are being sent. Number of URLs. So this is the space complexity of it, because see, we have to store it ultimately in the history array. Okay, so that is how it is being done. And coming to how fast my solution is, so yeah, this is the one. You can clearly see it's 98% faster. So I hope you liked my solution. Thanks a lot. If you liked my solution, please like and subscribe. And once again, thanks a lot.